Good morning. My name is Mark Brown. I'll be your instructor for this month. Today we're going to talk about Lec2, which breaks down to kind of an idea of how to make some state machines better. So you guys have already worked on state machines for a while now. You've done some stuff with your Lab 1 and your experiments 1 and 2. So you've kind of got a good feel of them right now. We're just kind of going to look at them a little bit more in depth and see how we can make things better, how we can improve some things. So what we're actually going to be talking about today is we're going to talk about helper functions. What are helper functions? How do we use them? We're going to do a little bit of discussion on failing gracefully, what that means, and things we can do to make it so our programs seem to work a bit better, our games seem to be working a bit better. And finally, we're going to look at how we can use state machines to help us keep things in scope and do some actually planning of our projects before we actually begin them. So what is a helper function? How these work? So helper functions are an issue that a lot of people run into, not really sure how to use. It seems very difficult sometimes to say, okay, if I do a little bit extra work here, I'll save some time later, but how do I know if that's actually the case, or I'm just wasting my time? And it's one of those things that unfortunately experience is going to be your best guide. Let's actually discuss what an actual helper function is. So if you have a problem where you have code that appears multiple times, you're using the same bit of code over and over and over again, and you copy and paste it, copy and paste it, copy and paste it. This causes problems because what if that code needs to change? So for example, in the stoplight, if you guys are just setting your stuff to red, yellow, and green, what if I decide, you know what, I want to be a rebel and I want to have a blue instead of a green? That means you have to go through your code and find every one of those references to the green and change it to blue. It's going to be an awful lot of work for you. So the solution to this is instead of creating these multiple functions over and over and over again, so multiple code calls, we can actually do a single code call and call that over and over again, giving you one place to change it once, and it goes and fixes itself. A thing I always like to use as a reference for when to use helper functions and how these actually work is a short story by a man named Robert Heinlein. You guys maybe know him because he was the guy that wrote Starship Troopers. He was a very prolific science fiction writer in the 1960s. He's also a bit of a pervert and kind of sexist. Again, it was the 1960s. He had a different society right then. You don't believe me? Watch some old episodes of Star Trek. You'll see what I'm talking about. But anyway, in The Tale of a Man Who Was Too Lazy to Fail, he talked about this command that wasn't necessarily lazy and saying, I don't want to do any work at all, but he was a man that said, I don't want to do more work than I need to. So he'd sit around and he'd say, you know what, if I worked 8 hours on this right now, I can do this task, or I can do that task in 1 hour, and I can do this task in 1 hour every day for the rest of my life. So suddenly that 8 hours doesn't seem like that big an investment. He starts off, he does this task in 8 hours, it takes a longer time, he has a lot more work in the front, but then at the rear end, he doesn't have to do anything for the rest of his life. Whereas someone who's doing this traditional way, the 1 hour every day, has to do that every day, 365 days a year. So that's kind of what the whole focus of the story was, the idea that it's not so much of being lazy, it's being constructively lazy. Decide what it is that you need to do the stuff you need to do, actually put that work in ahead of time so that you don't have to do that work later. That's what a helper function does for us. So let's look for an actual example. Let's get some more details on this. So these 3 lines of code were appeared everywhere in the Lab 1. I've seen these 3 lines of code about 1,000 times. So what we're doing here is we're finding the green light object, the yellow light object, the red light object, and we're setting them to their respective colors. So in this case, it's the red light state, the red light's turned on, everything else is turned gray. And again, these are 3 lines of code. It's not that big a deal. But these 3 lines of code get repeated over and over and over again. So let's look at a helper function we can set up to make it so we don't have to do that. So here's our helper function. Now the first thing I need to stress, you guys notice we have a bright red box surrounding it. Helper functions are always private. Helper functions are stuff that's going to work within your class itself. You don't need to worry about these ever. You don't want these to be ever accessed by anything else. This is all internal logic for this internal class. If something else gets access to it and actually tries to do these helper functions from an outside source, it can end up breaking things. We don't want to break things. So let's walk through this. So we have our green light, yellow light, and red light objects, and we're finding them. Pretty straightforward. We then immediately turn them all to gray because we want to make sure everything is at the default state. Then we check our current state. We say, okay, let's see what the actual current state is. The current state is green. We're going to actually turn the color of green 1 on, turn it to green. Yellow, we're going to turn the yellow light to green. Red, we're going to turn the red light to green. You see here, well, yes, we put an extra work here, but now we no longer actually have to put those 3 lines of code over and over and over again. On top of that, this is actually smart enough that we don't actually say what class is in. When we do that, we don't have to do any extra thinking. We say, set the color helper light in each of these states, and it turns the light for us automatically. That's what I'm talking about, that constructive laziness. We don't have to do any more work than we have to. We don't want to do any more work than we have to. So let's take a step away from that. We'll come back to that a little bit later. We can do some more with that. But for right now, we're going to talk about failing gracefully. So what is failing gracefully, Mark, you're asking? What does failing gracefully actually mean? To fail gracefully, in a nutshell, don't crash your game. So you guys have probably seen the dreaded null exception error. It's one of the most common errors we see in the game. What causes a null exception error? A null exception error occurs whenever you try to use something as if it's there when it's not there. So if it has a value of null and you try to access it like there should be actually be something there, it crashes. It says there's nothing I can do here. I'm going to fall apart and I'm going to crash the game. We see this thing all the time, so this is nothing new. Should not be nothing new to you guys. Here's a classical update from our lab where we have the FSM current state invoke, and that goes and goes and goes. But what if you try to call a state that doesn't exist? What if you tried to set up your state, you called it blinking, but then later you went around and changed the name and said, you know what, I'm just going to call that blink, but you forgot to change that name. When you tried to call state blinking, it would crash because blinking does not exist. So what we can do is a really quick if check here and put that around it. So we say, hey, if the FSM's current state does not equal null, then we'll invoke it. So it's going through, it's doing a check on that, says, hey, okay, is this actually here? If it is here, then we're actually going to invoke it. If it's not here, we're going to go into this weird zombie state and not actually do anything. You notice that if it's in this state, we're going to get stuck here. We're never actually going to get out of it. But at the very least, your game doesn't crash. And it's situations like that that get these wonderful examples. So we have this ungodly abomination of man here that, of course, looks rather horrible. But at the same time, your game is not crashing, which is the important bit. So as long as your game doesn't crash, we can actually recover from this. The player can actually go to the start menu, restart the game, go back to the actual game they want to do, and try to avoid becoming this ungodly abomination again. So things that we should be watching out for. The areas that you want to put these if checks around, things you want to check for null on. The most common ones are, I mentioned before, anything that you use GameObject.find on. If you try to find something that doesn't exist, so remember we're changing names of things. You decide you want to call everything green light, blue light, red light. Then later you want to say, you know what, let's change that blue light to green light. I don't know why I named it blue to begin with. You change that name, but you don't actually change the call in GameObject.find. It's going to return null. You're not going to get any actual values for it. The find objects function does the exact same thing, has that same problem. If it doesn't find something, it's going to return null. It's going to cause issues. Any variable where you use brackets to actually try to select something in an array, if maybe the array is not filled up, maybe the array or list doesn't have all that information in it, you can cause them to call no. And then that period operator as well. Now what that period operator is, let's be adults here. Let's call it the actual word. It's called the membership operator. So anytime you try to use the membership operator, you want to make sure what you're trying to get access to actually exists. So here's an example of the update function that actually kind of takes care of these things and doesn't actually go into that zombie state as we talked about before. So again, we start off, we do the if check. Does this state exist? Is it not equal to null? If it's not equal to null, okay, invoke it. If it is equal to null, we'll fall into this else statement. This else statement says, okay, we're going to go to a debug log. We're going to throw out that error to the screen so that the programmer knows what's going on. And he can fix that at one point and not actually ship this game, because you don't want to ship your game that's broken. But it lets you know what's going on, and then we set our state to a state that we know is safe. So in this case, we're using idle. Idle is being assumed in this case to be safe, but we always want to go with a state that we know is okay. So you do that first state. Idle should just sit there, should not have any problems. We'll use that, we'll call it good, we'll go into that safe state. It's not going to crash, it's not going to turn into some unholy abomination. The game may not work the way you're expecting to. If you try to pull the trigger and the trigger state is, I should call a fire, and the fire doesn't work, you'll know there's a bug there. But again, your game's not going to crash, it's going to fail gracefully. So here's an example of how that's set up. This is a kind of an RPG style game. Let's imagine this is Dragon Age Inquisition, though this is obviously it's not. So in Dragon Age Inquisition, you have your warriors and you have your rogues and you have your mages. Warriors and rogues and mages all use different weapons. So a warrior can use a sword, a rogue can use daggers, and a mage can use a staff. And so we need to make sure these are compatible. If we try to give a warrior a staff, we need to make sure it doesn't let us do that. So we have this is weapon compatible function. And what that does for us, it actually goes through and checks out and sees what is going on and make sure that this weapon that they're actually trying to use is allowed for them to use. So the first step here is we create a Boolean that says is compatible, and we set that immediately to false because we don't want to make any assumptions. If we were to set it to true, it may actually give us a false positive. We don't want that. So by saying false, it's going to immediately default to no, it won't work. Then we check and see this weapon add, which got passed into the function. Is that weapon add actually a value? Did someone actually pass in a null value, or did something get destroyed on the way there and it didn't actually work? If it is a null value, we'll follow through. We'll just return that original false. If it is compatible, we'll go into this function, this if statement, and we'll say, okay, let's look at the actual list. Does the list contain this weapon we are actually trying to look at? So the list of available weapons, the weapons that this guy can use, can he use the weapon we're passing to him? If that returns true, this is compatible becomes true, and we can return that value. So you notice there's a lot of cases where it will fail and only one case where it will work. All those cases where it fails prevents the game from crashing, prevents you from having a warrior running around with a staff. Then let's see here what happens here. We add the weapon. This is weapon compatible is actually a helper for this function. We had all this code we were going to repeat over and over and over again. We just put it in a single line here and called it good. So we have this add weapon. We pass the weapon into it. If the weapon is not null, again, do some protection here. Then we check and say, hey, is that weapon compatible? That function we called up before. Now you may notice we're being really paranoid here because we have this weapon to add is not equal to null. We also have a weapon to add not equal to null up here. That's fine. This may be a case where in your add weapon it may be doing this extra check, but other cases you may not have that extra check. This is weapon compatible. It's supposed to be generic. It has to be self-contained. It can work anywhere we need to use it. So we need to make sure that if we're using it somewhere where they're not checking that null first, it checks it again. Then anyway, the is weapon compatible. If that returns true, we're going to add the weapon to the list, and then we're going to call this imaginary function that actually equips it if it's the best weapon. Again, this is actually a bit of code we wrote here. It's not anything from an actual game, so this is just kind of stuff, a function that doesn't exist yet, but that's what we wanted to do. So let's go back to our set light helper. Let's take a look at that and make that a bit more bulletproof, make it so it's not going to actually cause these errors for us. So we created our green light, yellow light, and red light. We find them, and we say, okay, is that green light null? If it's not null, we'll set that color to gray, and if our current state is green, we're going to set that color to green. Else, if it is null, we're going to throw out a debug. So we say, hey, wait a minute, something's going on here. You need to fix this. Yellow, we do the same thing, the exact same code. Is it null? If the color is gray, it's the color gray. If it is, also set the value of it, etc., etc. Now, if you're looking at this, you're saying, wait a minute, Mark. We're repeating code here, and that's what we're not supposed to do. That's not lazy. So that's what we want to do here. We actually want to adjust this and approach this the way that we can actually make it too lazy to fail. So I say, you know what? This 3 chunks of code we're copying over and over and over again, let's create another helper function. Let's put that in that helper function so we only have to call that code 1 time instead of 3 times. So here's this new version that is much more streamlined. So we have this set color helper that is a more generic, again, a class that doesn't really care what color or what class you're currently in or what color you actually want to turn the light on. It works for all of those lights. So we set the color helper. We pass into it a string for the name of the object. We turn in the corresponding state, the actual state it's currently in, and then which color we want it to activate to. We go into the game object, we create a light, the game object.find of that game name, so just like we did before. If that light object exists, just like we did before, except for we're using a string instead of the actual hard-coded value. If that light object exists, we're going to go in here and we're going to set the color to gray, just as the default color. Then we check and say, hey, is the current state the state we should be in? If it is, let's go in there and set that value to the color we want. So if it's green, we're going to set the color to green. So if it's red, we're going to set the color to red, yellow, set the color to yellow. Finally, we have this else at the bottom here encapsulating everything, saying, hey, something went wrong. Here's the information you need to go and fix this. Then when we actually are trying to set these colors, we've got all this code written out ahead of time. We only actually have to call set color green light, set color yellow light, set color red light. 1, 2, 3. So we go from having to write up all this giant chunk of code here, or even just the 3 chunks of code before, to these 3 chunks of code here that are smart enough to take care of it for us. And these are going to be safer. They're not going to crash the game. They're not going to cause any issues. So again, that's the kind of idea here, failing gracefully. So the final thing we wanted to talk about is the idea of keeping things in scope. How can state machines help us figure out what's going on? What are state machines? State machines seem like an awful lot of work, Mark. Why do we actually want to use those? Well, this is kind of an issue when you're actually looking at your project. When you say, okay, I have all these items in this project, and you actually use the state machine to kind of give you an estimation of how much work it's actually going to cost, how much work it's going to actually do. And on top of that, it's also going to help you actually in your development of the project itself. So you have your behaviors of an object. You say, okay, I want an exploding barrel. My exploding barrel is going to have 3 states if I break that down, because I have an unexploded, I have an exploding, and I have an exploded state. I want these 3 behaviors based upon those 3 states. Well, that means I now know how many states it's going to take me, how much code I'm going to have to write to actually make this barrel explode. So I need to write up a state machine. I need to make 3 states, 1, 2, 3, and go from there. And like I said, this actually gives you a checklist as you're working on the project. So you're making an exploding barrel. You say, okay, I need to write 3 states. State 1, unexploded. Go through, set up that unexploded state. State 2, exploding. You check off state 1. That one's done. State 2 is exploding. Go through, make the exploding state. Check that off. That one's done. Go to state 3. Check off that state. This helps you kind of figure out how much stuff that you actually are working on. So if you're creating some game that has 500 states in a single object and you have 50 objects, you have this list right in front of you. You're like, man, that's an awful lot of stuff I'm going to have to write. Maybe we should cut things back and actually see what it is we need to be doing, what states we actually need versus what states we want. So that's what you can use state machines for, is help you figure out what it is you're actually working on, or what you're going to be working on, and see, okay, is what I'm trying to do too ambitious? Is it too big in scope? So that was it. That was the lecture. So what we talked about? We talked about helper functions. Again, the object you need to really focus on here, the lesson you need to focus on, is helper functions are a way for you to be lazy. It's something that you want to do when you're looking at code. It's like, why am I copying and pasting this code over and over and over again? I can write it once and never have to copy it again. So you use these helper functions to avoid doing that. We talk about paranoia, and it's actually usefulness in code. Making sure your game doesn't crash, making sure your game doesn't turn into some god-awful abomination for the movie The Thing. And then once you're done with that, we actually would cover some stuff on estimation, figuring out what it is that you're going to work on, how long it's going to take you to actually do this stuff, how big a task is actually going to be. And that's pretty much it. So if you guys do have any questions, please let me know. I'm happy to answer them, and that's all I got for you.